Hi, everybody. Thank you and for watching this lesson 5-1, writing linear equations from situations and graphs. And so the big essential question is, how do you write an equation to model a linear relationship given a graph or a description? Okay, so let's watch the video.
I love video games, and so do some of my friends. I'm here to buy this game. It costs $40. Now these games are on sale for $20, and I want to buy a few for my friends, but I don't want to spend too much. I need to figure out how much it's going to cost to buy different numbers of video games. That's where math comes in handy. We can represent this situation with a linear equation. Let's say I buy any number of these $20 games. We'll call that x. We can calculate the total cost by multiplying x by 20, then adding the cost of this other video game. Let's call the total cost y. Now we've got a linear equation. No problem. Now we just plug in different values of x, do some simple math, and we can figure out how much I'm going to have to spend. They do add up pretty fast. I better put a couple back. And that's why math matters.
Okay, so it is very important, and especially to compare prices, okay?
Many real-world problems can be solved by writing linear equations. Greta makes clay mugs and bowls as gifts at the Crafty Studio. She pays a membership fee of $15 a month and an equipment fee of $3 an hour to use the potter's wheel, table, and kiln. Write an equation in the form y equals mx plus b that Greta can use to calculate her monthly costs. Let's write an equation that can be used to solve this problem. Begin by identifying the independent variable and the dependent variable.
Okay, so it is confusing when you start reading this problem. For example, it says a membership fee of $15 a month. It also sounds like a rate. And then it says an equipment fee of $3 per hour, another rate. But it says Greta can use and help get Greta calculate her monthly cost. So as soon as they say monthly cost, then that means that the membership fee is the initial value. It's the y-intercept, and $3 is the slope. So $3 per hour. So that means that the hours are going to be the independent variable, and then the equipment fee will be the amount pays is the dependent variable. So number of hours, independent, and then the amount of money that Greta uses is dependent because it depends on the number of hours, okay?
Yes, that's right. The amount of money that Greta pays depends on the number of hours that she uses the studio. Now, let's find the y-intercept.
So during the month of April, Greta did not use the equipment at all. So she still has to pay what will be her number of hours. Since she didn't use it, it's 0 hours. And then what will be her cost? Well, she still has to pay for membership fee. So I'm thinking that the $15 for membership fee, and then her total, the y-intercept will be $15 because she still has to pay the membership fee.
That's right. Next, let's find the slope.
So remember, to find the total cost, if they give you that, it says Greta spent $8 in May, 8 hours in May. So you multiply 8 times 3, which is 24, plus 15, which is 39. And then if she spends 11 hours, it would be 11 times 3, which would be 33, plus 15 would be 33, 48. And then from May to June, the change in values, well, it went from 8 hours to 11 hours. So that's going to be 3 hours more. And then from May to June, the amount was 48 minus 15 is going to be 9. And so the slope is 9 divided by 3, which is 3. But I already knew that the slope was 3 because it says $3 per hour. Okay? So $3 per hour.
Great job! Now you can write the equation. Use the values that you found for M and B.
And I knew the equation before I wrote this. That's why they give it to you in the word problem. It says $3 an hour. Hours is the independent variable. The amount is the dependent variable. So that's why it's y equals 3x plus the membership fee, which is $15. Okay?
Here's the correct answer.
Oh.
The y-intercept is 15 and the slope is 3. So the equation is y is equal to 3x plus 15.
So I only read...
Greta can use y is equal to 3x plus 15 to calculate her monthly costs.
So it said write the equation, so I put y equals, and then the y equals was already there, so I didn't have to do that, okay? Sorry.
A video club charges a one-time membership fee plus a rental fee for each DVD borrowed. Use the graph to write an equation in slope-intercept form to represent the amount spent, y, on X DVD rentals. You can use information presented in a graph to write a linear equation in slope-intercept form. Let's begin by finding the slope. 2 points that can be identified on the graph are 0, 8, and 8, 18. Use these points to find the slope, first as a fraction, and then as a decimal.
So remember that the slope is the change in y. How much did the y change? Well, the y went from this 8 to 18. So from 8 to 18, you add 10, so it changed 10. And then the x changed from 0 to 8. 8 minus 0 is 8. So then it was 10 divided by 8. What will that be as a decimal? Let me see. Okay, 10 divided by 8, it is 1.25. So 1.25. Okay.
That's right. Next, locate the y-intercept on the graph. Enter the value found for the y-intercept, or b.
So remember, this is your y value right here. It went up, it touched at 8. So the y-intercept is 8.
Yes, the y-intercept is 8. Now, you can use the slope and y-intercept to write the equation of the line that passes through these points. Use the decimal form of the slope.
So the slope is 1.25, and then don't forget to put the x, and then the y-intercept is 8, so plus 8.
Yes, that's right. Let's interpret the result.
So the value of the slope in this equation, remember, slope is a rate. This does not show a rate. The amount of DVDs rented, that doesn't show the cost per, the word per. Yep, that's it. And then the y-intercept is just a one amount fee. The x represents the number of DVDs rented, so the y-intercept represents the membership fee, okay?
Yes, nice job. It costs $1.25 per DVD, and the membership fee is $8.
Any questions? Let me know.
The rent charged for space in an office building is a linear relationship related to the size of the space rented. Write an equation in slope-intercept form for the rent at West Main Street office rentals. You can use information from a description of a linear relationship to write the equation. First, we identify the independent and dependent variables.
So the independent variable, the square, see right here, this is the x, so it's the square feet, that's the independent, and then the amount of money is the dependent variable, the monthly rent. The monthly rent depends on how big the item is, the square feet.
That's right. The monthly rent depends on the square footage. Next, we need to write two ordered pairs in order to find the slope.
So right here, the two ordered pairs are 600 square feet for 750, and then the other one is the 900 square feet for 1150. Okay.
That's right. Now, find the slope of the line that passes through these 2 points using the slope formula. Don't forget to simplify.
So remember the rate of y, the change in y. How much did the y change from 750 to 1150? Well, the 50s cancel out, but 11 minus 5 is 400. So 400. But then I have to reduce. So it's 4. I'll just put 4 because look at the zeros are going to cancel. And then from 6 to 9, it's 3. So it's 300. And then the zeros cancel out. It's 4/3.
Great job. The slope is 4/3. Next, find the y-intercept. To do this, substitute the slope and one of the ordered pairs into y equals mx plus b.
So notice, to find the y-intercept, they started with the equation y equals mx plus b. They substituted, they used this point 600 and 750. So for y, they substituted 750. For the slope, we said that the slope was 4/3. So I'm going to substitute it in there. The x right here was 300. And then we don't know what the b is, so we put plus b. Then 4/3 times 600, this is the way I do it, okay? 600 divided by 3, 6 divided by 3 is 2. That's 200 times 4. 2 times 4 is 8, so it's going to be 800. And then I got to subtract 800 from both sides to get the b alone. So 750 minus 800 is negative 50, okay? So that's the y-intercept.
Great job. That's it. Now you can write the equation of the line that models this situation.
So we know that the slope is 4/3. Put it right there. And the y-intercept is negative 50. So we put minus 50. Okay. Usually the minus will go instead of plus. We put minus 50. Okay.
That's right. Now let's practice with.
So number 1, it says complete the description of what m and b in the equation y equals mx plus b tell you about the graph of the line with the equation. So the of the graph line is m. M represents the slope and b represents the y-intercept. I check it and it's correct. Then I go to the next one. And then it says complete the description of what would be true about the rate of change in a situation that could not be represented by a graph line and an equation in the form y equals mx plus b. The rate of change would not be constant. Using different pairs of points in the slope formula would give you complete that. The rate of change. The rate of change would be constant, and it doesn't matter which points you use, it'll be the same. So once again, the rate of change would be constant. Using different pairs of points in the slope formula would give you the same result because that's the rate of change. That's the slope. Cannot. Recall that in an equation in the form y equals mx plus b, m is replaced by a constant value, and that slope is the same between 2 points. The equation asks about a graph that cannot. Oh, that's what I thought. Okay, cannot. If they cannot be, it would not be the same, and it would be a different value. Okay? Cannot. That's what I thought in the beginning, but then I switched. Go always with your first instinct, okay? Thank you so much. Bye-bye.